So this exercise assignment related to the SI quantities, graphs, and motion. The doubt first, question 3. In question 3, the diagram below shows the velocity of an object before and after the force is applied. The magnitude of the velocity did not change. Which of the following arrows represent change in the velocity? Look, what is the meaning of a change in velocity? Change in velocity means, like if I say in the beginning, that is V1, and the final is V2. What is the meaning of a change in velocity? It is V2 minus V1, like the difference. So how to get V2 minus V1 in terms of vector addition? So first it is written V2. And actually in terms of vector, what V2 minus V1 means, it means V2, then plus, and then minus V1. Means the vector V2 is added to the vector minus V1. So if V1 is up, what will be the direction of the vector minus V1? That will be downward. Now, when we find the resultant here, first we draw V2 because we want to change the difference. So first we drew V2. So that is V2. And then we have to draw minus V1. So what is the minus V1? Minus V1 is pointing downward because we are finding the difference. So this is minus V1. And what about the resultant? What is the direction of the resultant? Resultant is always from tail of the first to the head of the last. And you should also draw according to the size which is given in the question. So when we draw, like we do the V2, let's say this is 2 centimeters, so we'll draw 2 centimeters. Then say V1 is say 3 centimeters, so we'll draw 3 centimeters, but it is minus V1, so we'll draw minus V1, means opposite direction. And what about the resultant? Resultant is always from tail of the first to the head of the last. That is a resultant. So when we find the resultant of these two vectors, so tail of the first to the head of the last is a resultant. So which option it matches with? So it matches with option B. Is it clear? Question 3. How we get the change in the velocity?
Yes, sir.
Yes.
Next is question number 4, the doubt. In question 4, two objects are there. P and Q are at the same point at time t. The graph shows how the velocity v varies for each object. Which of the statement describe the position of a PQ at time t is equals to 4? Look, this is a velocity time graph, and velocity is a vector quantity. So when it is a +1, it means the object was moving towards the right hand side. Like if we say, so positive velocity. And when it is, so for first 2 seconds, it was moving towards right. And for next 2 seconds, it was moving towards left because the velocity is negative. So what it shows? It shows that because the area under the graph represents the displacement, so the displacement towards the right is same as displacement towards the left. It means the object P will return back to its original position. So first it moved with a specific speed of 1 meter per second for 2 seconds towards right, and then it moved in backward for 1 second, for 2 seconds with a speed of minus, means the direction is opposite. So it returned back to the same starting position or same initial position. So the displacement of P is 0. But here, what is happening for Q? The slope is decreasing. It means acceleration is decreasing, but the direction does not change. Means its velocity is changing. The change in velocity is decreasing. Like first, maybe it was 0.5, the velocity. Then the velocity might be 0.7. Then the velocity might be 0.8, 0.9, and then or 0.85, and so on. So the acceleration is decreasing, but the direction of the motion does not change. So which of the following statements describe the positions of P and Q at time 4 seconds? P and Q both are initial position. That is wrong. P is at initial position, but Q is not, because Q does not change the direction. P and Q are same distance from initial position. That's also wrong. P actually travel and then return back where Q continue to move. That's why it is wrong. P is further from the initial position than Q. That is also wrong because P actually returned back to the starting or the initial position. And the last option, Q, is further from the initial position than P. That is right because P actually traveled and then returned back. So P is at its initial position where Q continued to travel in a specific direction from the initial position. So D, option D is the right answer for this. Is it clear? Question 4.
Yes, sir.
Yes.
Then we have question number 10. Question 10, a student carry out an experiment to measure the acceleration of a free fall. So student want to measure the acceleration due to gravity of acceleration of a free fall. A ball bearing was released from a position A. So what is the initial velocity when something is dropped from certain height? So initial velocity is 0. Then how much time does ball bearing take to travel from the electromagnet till the tap switch? That time using a timer we record, and we measure using a meter rule or a meter scale. We'll measure the height, and then we'll use a formula. We have the formula S is equals to ut plus half at square. So S is actually the height, the distance from which it is dropped. So it is L here in this example. U is 0, so this whole factor will be 0, so it will be 1 by 2. And when falling object, if we consider a short distance or without air distance, acceleration will be due to gravity, so it will be g and t square. So basically the equation is L equals half gt square. So what we will do, we will plot a graph, we'll compare with the equation of straight line y is equals to mx. So on y-axis, if we plot the length, on x-axis, if we have t square, then what will be the gradient? It will be a straight line because the constant gravity and 2 are constant. So the gradient of this graph will be g by 2, or gradient multiplied by 2 will give us the value of gravity. So explain how the measurements obtained can be used to determine the value of the g in meter per second square. Explain. Your answer should include a sketch on the axis below, a graph that student would expect to obtain. So what graph student expect to obtain as the initial velocity is 0? So it will be a straight line which is passing through origin. Why the straight line must pass through origin? As there will be no y-intercept when we are using this equation. So plotting a graph between L and t square, where the gradient of this graph is g by 2, or we can say gradient times 2 will be equal to gravity. So the points which we will include, we will first mention that initial velocity is 0, and the graph between the time square on x-axis and the distance on y-axis, the gradient will be equal to half of the gravity, or the gradient multiplied by 2 will give us gravity. So it will be a straight line passing through origin. Why there is no y-intercept? Because when we work out this equation, S is equals to ut plus half at square. So S is a distance, which is a length, u is 0, so this whole factor is not there, it is half dt square. So there is no quantity which is added, that's why the y-intercept is 0. Y is equals to mx plus c, so there is no nothing added or 0 is added, that's why the y-intercept is 0. Is it clear? This question 10.
Yes, sir. Sir, but for the y-axis, why don't you take 2L, means twice the length, then the gradient will be equal to the acceleration.
If I take what?
Sir, just 2L on the y-axis, as you wrote the equation for acceleration. Why
Yeah,
didn't
but
you take just 2L?
I can take, but normally when we take a variable. We don't take the constant, involve constant in the axis. Like we normally don't plot, you don't plot a graph for 2a versus y. When we plot, we use a variable, or 2a versus x. You don't plot that. Normally, when we plot a graph, it's like the variable. So the thing which can change is L, not 2L. If L change, definitely 2L will change. But as you see, L equals 1 by 2. GT square. What you're saying, this 2 is divided, I should multiply there, so 2L is equals to GT square. Then you're saying I should compare Y is equals to MX. So quantity, the variable which we plot on Y-axis should be separate, like it should not have any constant value with it.
Okay.
So that's why we are not using 2L, we are using only L, length. Then question 14 is there. Which of the following graphs of displacement against a time could represent the motion of a ball? So basically, it is about, so we have which of the following graphs of displacement against a time to represent the motion of the ball, but this one is, the question is actually related to this 13. This is a velocity time graph. So velocity time graph, and this velocity time graph, now we have a displacement time graph. So what happened when you see this? Here we have a positive velocity, because question 14 is actually related to question 13. So here what happened to velocity? Velocity is increasing. When we check the velocity, the value of the velocity is increasing and it is positive. Then the velocity value is decreasing and it is negative. And remember, if we have a displacement time graph, so what happened to displacement time graph? The slope represents the velocity. So if this is what happened to velocity. So what happened to slope? The slope should increase and it should be positive. And then the slope should decrease and the value of a slope should be negative. So we have to check which one the slope is positive and increasing, and then the slope is negative and decreasing. So we want to check the graph, displacement time graph, for which the first one, the slope, the first part, the slope is positive. That is one thing, like the value of a slope is positive and it is increasing. And the second part of the graph, the slope is negative and it is decreasing. Now, when you check this one, first, what happened to this part? What about the slope? The first part. So slope is positive because y2 and y1, so y2 is above y1, so slope is positive. And what happened to the slope? It is increasing. The angle with the, because what happened to the fence, the slope is increasing and it is positive. But when you check the second part, what about the slope when you take y1 and you take y2? So y2 is above y1, so slope will be positive. Even though the slope is decreasing, but slope is positive. But what we want a graph for a displacement time for which the slope should be positive and increasing, and then the slope should be negative and decreasing. When you check option B, it's a straight line. So straight line means slope is constant. So even it cannot be an answer. When you check option C, first part, the slope is positive and it is increasing. And the second part, when you check, the slope is negative and it is decreasing. So we want this. That's why option C is the right answer. Why D is totally wrong? Because again, it is a straight line and straight line slope is constant. So it cannot be A, B, or D. It is option C. Is it a clear discussion?
Yes, sir.
Yes.
Then question 21 part D. Question 21. Suggest why the initial acceleration and average accelerations are different. If you read the question, the mass, because it's a rocket, a secondary rocket used in NASA program, had a mass of 3.0 exponent 6. It took off vertically and the thrust. For rockets, as they're consuming a fuel, the mass is not constant, the fuel consumption is there, so the mass is changing. That's why the initial acceleration will be different as compared to average acceleration, because the mass of the rocket is not constant, as the mass is having an effect on the acceleration as well. So mass is changing. Due to change in mass, the resultant force will change, and as the resultant force will change, the average acceleration and initial acceleration won't be same. Then question 33. The diagram shows the forces acting on a picture of weight W suspended by a cord. The tension in the cord is T. Which of the following expression shows the correct relation between the W and T? Now, what we do whenever we have a vector, we resolve the vector into components. The component of a vector which is with an angle, that is called T cos theta, because it's a breaking down of a vector into component. And the component of the vector which is against the angle, that is T sin theta. So T sin theta is acting up. Same thing, this angle is also theta. So the component of a vector which is with an angle T cos theta and against the angle will be T sin theta. So T sin theta and T sin theta are acting upward and weight is acting downward, but because it is in equilibrium, so the total upward force, there is no resultant force or total upward force equal to downward force, as it is in equilibrium or balance. So it will be T sin theta, which is up, T sin theta, which is also up, and weight is acting downward. So when we sum the total upward, so 2T sin theta equals to weight, or weight equals to 2T sin theta. So question 33, it matches with option D. So D is the right answer for this. And question 34A, 1 and 2. In question 34, the photograph shows a sequence of images of a bouncing tennis ball. The photograph plot, the student plots the following graph and claims that it shows the vertical motion of a ball being photographed. Without carrying out any calculation, describe how the following can be found from the graph. The vertical distance traveled by the ball from 0.5 to 1. So how we can find the vertical distance? If we have a velocity time graph, or if we have a speed time graph, if we want a displacement. So what we do, we find by using the area under the graph. So by simply we'll use the area under the graph or area of the graph. We'll work out the distance traveled between 0.1 to 1 second. So we'll find the area under the graph between x and y. And velocity time graph, the acceleration at y, how to calculate acceleration at y. Velocity time graph, remember the gradient or the slope represent acceleration. So it's a straight line. So what we can take, because it's a straight line, so we'll take a gradient from either from x to z, or we can take from y to z, or from x to y, or y to z, or x to z. That will give us the expression of this ball. So for acceleration from velocity time graph, we'll use the gradient. For area, for distance travel or the displacement, we use the area under the graph. Is it clear, this one?
Yes.
Yes, sir.
So any
Yes,
other
sir.
question? Any other question or a doubt? Because these are the questions which you have sent related to
Yes,
the
question 15.
Question 15. Okay.
Yeah.
Okay. In question 15, a skydiver jumps from an airplane and accelerates until she reaches a terminal velocity. At time T1, she opens a parachute and a second lower terminal velocity is reached. before landing safely at time t. Acceleration time graph is given. This is an acceleration time graph. Explain the shape of a graph. You should refer to the forces acting on the skydiver. So if you remember, the similar, like the same motion of a skydiver graph was there in IG3ST, that when a parachute trooper or a parachutist jump from a certain height, we have to explain its motion and using the graph. So first, the moment when he jumps, his acceleration, because initial acceleration is always equal to acceleration due to gravity. So the moment when the skydiver jumps, so consider a parachute is jumping from the aircraft. So the moment when he jumps, the weight is a force which is acting, and that weight will produce a constant acceleration. The gravitational force is there, and his acceleration will be equal to acceleration due to gravity, which is 9.8. In A levels, it's 9.8. So you will always take 9.8. But when he jumps, his speed is start to increase. As a result, what happened? The air resistance will also increase. As the air resistance increase, the resultant force will decrease. Like example here, the resultant force is say 100 Newton, but as the air resistance is there, so resultant air resistance oppose the motion, so resultant force will be 80 Newton. And we know resultant force and acceleration are directly proportional. So resultant force is decreasing, so acceleration is also decreasing. So this part you can see what is happening. In the beginning, he's having a maximum acceleration, which is 9.8. But as he jumps, his speed increase, so air resistance also increase. So resultant force decrease, that's why his acceleration start to decrease. Then what happens when the air resistance balances with the weight? The moment air resistance balances with the weight, so there is no resultant force. And the moment when there is no resultant force, like example, 100 Newton is downward and 100 Newton is upward, so resultant force is 0. If the resultant force is 0, it means his acceleration will be 0. So at this point you can see his acceleration is 0. It means at this point the weight and air resistance are balanced, or that there is no resultant force. But the moment he opened the parachute, more air resistance than the downward force. Now what happened, like example, the downward force is 100, but now air resistance is 150. So there's a resultant force upward, which is 50 Newton. So resultant force is opposite to the direction of the motion. What this will produce a deceleration, or we also say a negative acceleration. That's why the graph here, you can see a negative acceleration, deceleration. So at this part, at time t1, he opened the parachute, so air resistance more than the weight. So greater upward force than downward force, so resultant force is opposite to direction of the motion. So he will decelerate, negative. Then because he's decelerating, so his speed is start to decrease, so air resistance also start to decrease. So the resultant force will also decrease. As a result, when the resultant force decreases, the acceleration will also decrease. And again, he will reach a constant velocity, which we say a lower terminal velocity. So first, he's having because you can see here, the acceleration is constant. Then here the acceleration is decreasing. Here acceleration is 0. Here acceleration is negative, and again acceleration is 0. Here acceleration is negative and decreasing. So same thing is there in the graph, that the moment he jumps, he's having a maximum acceleration. Then acceleration start to decrease. Then air resistance balances with the weight. At T1, he opened the parachute, more upward force than downward force, so decelerate or negative acceleration. Then speed decreases, so acceleration also or deceleration also decreases until he reaches another terminal velocity. And at time T2, he landed the ground with a lower terminal speed or velocity. Is it clear, this part? Question 15. The motion of a skydiver.
Yes.
Yes, sir.
Okay. So any other question from this assignment? SI quantities, graphs, and motion?
No, sir.
Okay.